Graphing a complex number is a little bit of a crazy thing, but it's not because a complex number has two parts and an ordered pair has two parts. So if I wanted to graph 4 plus 0i, I have an imaginary axis and I have a real axis. So even though these are imaginary numbers, I'm really just graphing the coefficient. So 4 plus 0i would be right over here at basically 4, 0, right? This corresponds to the ordered pair 4, 0, nothing tricky about that. 0 plus 4i, 1, 2, 3, whoops, it's up here above the e, probably, corresponding to the ordered pair 0, 4. 2 plus 3i, 2 plus 3i is right over here, right, corresponding to the ordered pair 2, 3. Complex conjugate, whoa, okay, conjugates, you know, are basically a plus b and a minus b. So the complex conjugate of this is going to be 2 minus 3i. So I'm just going to plot the point 2, negative 3. 2, negative 3. So notice the complex conjugate is right above and below. Square root of 2 plus I square root of 2. That's a little bit tricky because square root of 2 is about 1.4. I don't know, maybe somewhere up there, right? So this is going to be the ordered pair square root of 2, square root of 2. And 1 minus, oh my goodness gracious. So I have to go over 1 and then down about 1.7. Such a pain. Okay, but let's talk about this a little bit more. So I often am looking for the magnitude of a complex number. And by magnitude, we might even call it the absolute value, but get it out of your head that absolute value means make it positive. Absolute value or magnitude is the distance from the origin. So let's come back to what we have over here. When we have square root of 2 plus I square root of 2, square root of 2, and this, granted, I'm just graphing the coefficient, I know that the magnitude of this for e, the magnitude of square root of 2 plus I square root of 2, well, that's just going to be, I'm just going to multiply by square root of 2 because I know this is a 45, 45, 90 triangle, and that's going to give me 2. And likewise, you know something's up here. I went over 1, I went down square root of 3. We all know that the magnitude for this one, for f, so the magnitude of 1 plus I square root of 3, the magnitude of that is going to be 2. The magnitude of 4 plus 0i, 4 plus 0i could not be easier. We can just count over 4 spots. And for b, same thing, 0 plus 4i, the magnitude of that is just going to give us 4. And the magnitude of 2 plus 3i, well, I'm not even going to draw this, right? But we know we have gone over 2, we've gone up 3, right? Over 2, up 3. We know the magnitude is the distance from the origin. So the magnitude is the length of that hypotenuse, which the length of the hypotenuse is just going to be 4 plus 9, right? B squared plus A squared, whatever. That's square root of 13. And for D, we're looking for the magnitude of, in this case, 2 minus 3i, and obviously that's going to be the same thing. 2 squared is 4, negative 3 squared is 9. And again, I'm just using the coefficient, right? I'm not using the I. That's going to become 4 plus 9, which again is square root of 13. So if we're looking for the magnitude, this is going to be equal to a squared plus b squared, and we're going to take the square root of the whole thing. We're just looking for the hypotenuse of a right triangle.